Hi everyone, it's Miss Potts and I hope that you are ready for an awesome lesson. So let's go ahead and take a look at the focus. The focus for today's lesson is to find multiples and factors and to use prime factorization. And by the end of this lesson you should be able to answer the question, what is the process of prime factorization? In our last lesson we already talked about factors. This lesson we're going to be talking about multiples. A multiple is a product of a number and any non-zero whole number. So examples of this is multiples of 3 and 4. So you're pretty much skip counting. So multiples of 3 are 3, 3 plus 3 is 6, plus another 3 is 9, plus another 3 is 12, plus another 3 is 15. And we're asked to also find the multiples of 4. So we count by 4s. 4, another 4 is 8, 8 plus 4 is 12. And see on this example how both for the multiples of 3 and 4, the value of 12 is circled twice in pink and in blue. That's going to directly correlate with this, the least common multiple. That is the smallest multiple of two numbers that is the least in common with both. So when we found the multiples of 3 and 4, we found the smallest number that's in common, the smallest multiple in common with both of those values. So what we're going to do now is find the least common multiple of 4 and 10. To do that, we need to list out the multiples of each value. We have 4 and we have 10. So like I said, we're going to skip count or use repeated addition to find all of the multiples of 4. First we have 4. 4 plus 4 is 8. Another 4 is 12. Plus another 4 is 16. Plus another 4 is 20. Plus another 4 is 24. And we're going to stop there and see if we can't find a least common multiple of 10 as well. So a multiple of 10 is 10, plus another 10 is 20, and right then and there I can stop because both of the value 20 is the least common multiple of both 4 and 10. So we're going to write that over here. The least common multiple is equal to 20. So let's go ahead and review what factors are. Factor is a whole number that divides another whole number with a remainder of 0. So this is an example of the factors of 36. 1 times 36 is 36. 2 times 18 is 36. 3 times 12 is 36, and so on and so forth. They are all factors of the number 36 with the 0 remainder. Also, let's review what a composite number is. A composite number is a whole number that has more than two factors. So here we have numbers listed and all of their factors, all the numbers that are divisible by those values. On the other hand, prime numbers are numbers that are only divisible by 1 in itself. So an example is the number 43 because it only has two factors, 1 and itself. And on our next slide, we're going to take a look at a chart that lists out our prime numbers. What I would suggest for you to do is to just take a moment and pause this video and write down a few of these prime numbers. So highlighted are prime numbers. They are only divisible by 1 in itself. And when we use prime factorization, we need to be able to identify what those prime numbers are. So go ahead and take a moment and jot down the prime numbers of 2 through 19. And then we're going to move forward to practicing solving prime factorization. Prime factorization is writing a composite number. So a composite number is a number that has more than two factors. And we're going to write it as a product of its prime numbers. Product meaning the answer to a multiplication problem. So we're going to use a factor tree to find the prime factorization of 54. The number 54, since it's an even number, is divisible by 2 because it's an even number. And we're going to begin the factor tree by dividing 54 by 2. 2 times what number equals 54? That's 27. We're circling our values that are prime because we automatically know right then and there that that limb of the factor tree is done growing. It's a prime number. There are no other factors for it. Next, we're going to break down the composite number of 27, which we have a prime number of 3 times 9 is equal to 27. And then we're going to branch off of the value 9 and break that into two prime numbers. And you're going to stop when all factors are prime. And like we said, we're going to write that composite number of 54 as the product of its prime numbers. So we're going to multiply. So the prime factorization of 54 is 2 times 3 times 3 times 3. Or another way to write that would be 2 times 3 to the third power, because our value 3 is being factored 3 times. Let's go ahead and take a look at an example and solve this together. We're going to use a factor tree to write out the prime factorization of 60. So first we're going to write our composite number of 60. I know by my divisibility rules, because 60 ends in a 0, that it's divisible by 10. So I'm going to branch off and say that 10 multiplied by 6 is going to equal 60. Neither of these values are prime numbers, so I need to break them down further. What two values are multiplied together to equal 10? Well, 2 times 5 is equal to 10. And if we go back to our prime number chart, we can identify that 2 and 5 are prime numbers. So we can go ahead and circle those values because we know that that branch has ended. Now we have the composite number of 6 that needs to be broken down into prime numbers. The two numbers that are multiplied together to equal 6 are 2 and 3. And again, if we go back to our chart that lists out our prime numbers, we will see that 2 and 3 are prime numbers, and we can circle those as well. Writing out the prime factorization of 60 would be 2 times 2 times 3 times 5. Or another way to write it would be 2 squared, since 2 is being factored twice, times 3 times 5. What we do to check our work is to go ahead and multiply these values. 2 times 2 is 4, times 3 times 5. And if we go ahead and use a calculator, you can multiply 4 times 3 is equal to 12, and then 12 times 5 is equal to 60. So we can double check our answer just to make sure that our factorization, or we're writing our prime factors that are being multiplied together, we can double check that to make sure that it equals our composite number. Let's go ahead and do one more example together where we're asked to do a factor tree of 26 to find the prime 126 to find the prime factorization. 126 I know is divisible by 9. So what number times 9 equals 126? That is 14. But 9 and 14 are not prime numbers. I cannot circle them. So I'm going to break down the value of 9 into 3 times 3 to equal 9. And both of these values are prime. They only have two factors, one in itself. But 14 is a composite number, so we can break that down further. Let's branch out and multiply 7 times 2 to equal 14. Let's go back to our prime number chart to make sure that 7 is a prime number. And it sure is. 7 is only divisible by 1 in itself, so then we can go ahead and circle those prime numbers as well. And we're going to write out the prime factorization, 2 times 3 times 3 times 7, or another way to write that would be 2 times 3 to the second power times 7, because 3 is being factored 2 times. Now let's go ahead and talk about what we learned about in this lesson and see if you can answer this question. What is the process of prime factorization? Make sure that you are going back into this lesson to review what prime numbers are, what composite numbers are, and what prime factorization is, and what factors are. If you have any questions regarding this lesson, please don't hesitate to let me know, and I will see you in class. Bye, guys.